Hey everyone, Jake here with NI at IMS 2023 in San Diego. I want to walk you through our connectivity and cellular test bench demo real quick. So first, let's take a look at our hardware here. So in the PXI chassis, I have the latest and greatest VST3 with some RF switches, and then an SMU, as well as a digital pattern instrument to control the DUT I have here. So the DUT I've got is a Wi-Fi 6 802.11ax PA front-end module. And I've got a few different RF paths in here controlled by the RF switches so that we can characterize this front-end module. So the demo here is just showing you that with the same flexible hardware system and software-defined test and measurement system with a couple of different software tools, we can do both interactive measurements for quick device validation as well as automated characterization. So first, let's do the validation. So here in Instrument Studio, I've got our native software panels showing support for our DC power instrumentation as well as our digital pattern instrument. I can quickly turn on the device. So I turn on my SMUs, and I can see for the different pins of the device here, the VDD and VCC1, I have my voltage and current plots to the left here in real time. And then to talk to my device and get it ready for RF, I will turn on the semiconductor device control software, and that's controlling my digital pattern instrument. I can run a script to turn on GPIO lines as well as run digital communication. So here it's a simple GPIO, flipping this, the bit here and turning my PA enable line on. So I run that script. I can see here my device is on, it's ready for RF. I have a quiescent current of 145 milliamps approximately. And so now, controlling the vector signal transceiver, again, natively in Instrument Studio, I have the RF signal generator and analyzer software pulled up. And so I've already pre-configured this for my measurement. So now with a couple of clicks of a button, I turn on the generation, the analyzer is running, and I can capture that RF signal so I can see my 80 megahertz 802.11ax signal. And then if I want to look at the specific personality here and do a WLAN specific measurement, I have the WLAN personality for my analyzer. And so really quick as a validation engineer, I can just do a quick sanity check, make sure my device is on, I've got power, and I've got the RF signal being amplified, and I see EVM, and I say, okay, this is good. Now, a quick note here, this is all native to NI's instrumentation, but we do also have Measurement Link, which allows you to take third-party instrumentation APIs, such as this Brody and Schwartz power meter that we see here, connected to the input power coupler. And in Instrument Studio now, I use that wrapper to then connect this instrument, and so it doesn't really matter where the instrument comes from. All I care about is taking a measurement, so in real time, I can actually capture that input power with a third-party instrument. So anyway, that's the interactive workflow for a validation engineer. Now let's look at automated characterization. So I'll close this software real quick. Just close these panels and close this one as well. So I'll turn off the PA. You can see it in real time, turning off. Turn off my SMUs. And what I'll do is I'll leave the RF instrumentation up because I can actually monitor what's going on. So as I'm running my automated sweep here in test in, I've already written my characterization test. I'll just execute that test. And what we'll see is we're actually pulling in the code modules to control the DC power, the digital pattern instrument, the RF instrumentation, and the RF switches. And we're sweeping through all these test points. So of course in characterization, I could run every single measurement myself, but I'd rather just let the software control that. So sweeping through power levels, frequencies, we're changing the RF path. You might have heard the clicking noise of the RF switches, and collecting EVM, harmonics, P1 dB compression, quiescent current, all the test points that you need to fully characterize your front-end module. We're doing that in an automated fashion, and now you saw that the data was updated live in Instrument Studio. We have our report and test in, and so normally you'd stop here, but now with NI's new data connected workflow, we can move on to Data Studio. And what I can see here is this is historical data from our previous run, but the power of the software is that now I can take that data and visualize it without having to do any extra work. I can just pull in that data. I can click over different conditions. So let's look at target power, and let's look at the EVM, for instance. So I want to see that bathtub plot to see what the EVM was over my power sweep. And just like that, I can see data insights in seconds instead of hours or weeks or months of analyzing data. And so that's the connectivity and cellular test bench demo. To learn more, please visit ni.com/semiconductor.